जय सोमनारायण. We have completed our first chapter in online study and उसमें हमने इलेक्ट्रिक चार्ज एंड इलेक्ट्रिक फील्ड के बारे में डिस्कस किया, राइट. Those all topic regarding static electric charges, and we discuss about electric forces and electrical field, about single or multiple electric charges, right? Okay, now we start our second chapter today, which is electrical potential and the capacitance, right? Okay, so again फर्स्ट चैप्टर में भी हमने स्टेडी चार्जेस भी डिस्कस किए, यहाँ पर भी हम स्टेडी चार्ज ही डिस्कस करने वाले हैं. दैट मींस as we discussed in very first lecture that both this chapter first and second are regarding static charges only. Got it? Okay, now first topic is electrostatic potential. What is electrostatic potential? To understand this thing we have to go with some other concepts. For example, first and very important is conservative field. What is conservative field? First question arises in your mind. We already discussed about conservative field in 11th science, right? Conservative field है क्या? First, so कोई भी फील्ड हम डिस्कस करते हैं. फॉर एग्जांपल 11th में कौन सा फील्ड डिस्कस किया था? ग्रेविटेशनल फील्ड. गॉट इट? ओके, नाउ लेट वी हैव वन बॉडी. I have this mass chalk stick, right? If I allow this chalk to free falling like this, right? So what happened? It moved in downwards, right? Okay, so what? Let this is the initial position of the chalk stick, and this is the final position of the chalk stick after some time, say t, right? Okay, now when you take shortest path between initial and final position of the chalk stick, this is the displacement occurs by the chalk stick in a given time t. You getting my point? Okay, now when it takes some displacement, so question arises in mind, why it take some displacement, why it travel some distance? Because of the external gravitation force exert on the body, force acting on the mass of the chalk stick, right? Okay, so when you take force and this displacement comes in the picture, then we can find out work done by the chalk stick, right? Okay, this work done is depends only on initial and final position of the chalk stick. Initial and final position of the chalk stick. You getting my point, right? Okay, now for example, let it is something weird to think about, but let anyhow if body is moving like this in a gravitation field, you get my point, under any circumstances, under any force, for example. So what happened? I want to find out work done by the chalk stick. So which distance you will take in your account. This is on the shortest path by the chalk stick. Okay, that means again initial and final position comes in the picture, right? No, this path will doesn't matter here, right? Just हम ये displacement ही picture में लेंगे as far as the work done by the chalk stick is concerned. You getting my point? So a field in which work done by body is depends on the initial and final position of the chalk stick, not path chosen by the body, right? Those fields are called conservative field, or we call it as conserved field. I hope you understand, right? Again, gravitational field is conservative field, gravitation field, and electric field is also conservative field. Okay, so this is the definition here. Conservative field, a field in which work done by the particle. Which particle we take? If we deal with the gravitational field, then we have masses, and if we have electrical field, then we have charge, right? So particle is depends on initial and final position of the particle and not on the path joining them. Such field is called conservative field. Again, conservative field, that means in which a field in which work done depends on initial and final position of the particle but not depends on the path chosen by the particle. Those fields are called conserved field. I hope you understand. Okay. So now let me move to the concept electrical potential. Right. इलेक्ट्रिकल पोटेंशियल हमें फाइंड करना है. क्वेश्चन है किसका और कहां पे. राइट. सो फर्स्ट लेट मी टेक दिस geometry. We have this arrangement. We'll go with two charges. How many? Two charges. First, capital positive Q. Right. Okay. Plus Q. Right. And other small q, which is again positive. Right. That means I will go with pair of a charge which is positive, right? Positive. Okay. I fix this q over here. Say a reference point. What is in O? If you go with the Cartesian coordinate system, right? Okay. Now, initially, this q is at infinite distance. Initially, this small q is at infinite distance. This is something like our q is a source charge, and small q we use as a test. Got it? Electrical potential is actually characteristic of charge, characteristic of source charge. You get my point, right? So let we take this q from infinite here initially, which having value 1 unit. How much? 1 unit. We call it as unit positive charge. What do we call it as? Unit positive charge. Okay. Now I want to find out potential at any point, at any position in the electric field of the source charge. Right? Okay. So let this is the point P in an area of the electrical field of the source charge Q over here. Right? I want to take this Q from infinite to point P. You get my point, right? Okay. So होगा क्या इससे क्या होगा? For example, इस पोजीशन पर पोटेंशियल इस चार्ज का क्या है हमें यह नहीं पता. Got it? Okay. When you take this plus q from infinite to point P, look at the sign of charge. Polarity of both the charges is positive. So when you take this charge from infinite to P, what happens? Repulsion. There is electrical force between these two charges, but since this is like charges, it feels repulsive force, right? Okay. Due to repulsion, this charge has to do work against the field. This charge has to do work against the field of the Q, right? So whatever work done will store in terms of potential at the point P. Got it? Okay. So first, let me take our entire path is divided in a small displacement elements here. In a small displacement elements, right? This path is very long, for example, compared to the dimension of the magnitude of the source charge. Right? Okay. So I want to first move this charge Q from infinite to a point P which having a distance dr. Let this is the displacement here. Okay. So when you move this charge towards the positive, you have to push this charge to overcome the repulsive force of the source charge. Why? Because again, positive, that is why. Got it? Okay. Now, how much force is needed to push this charge Q is the F external force. What do you call it as? F external force. You getting my point? To move Q from point R to point P. R point is taken as infinite. You getting my point? We just largely discussed. Point B, external force F external is needed enough to overcome effect of the repulsive force due to plus Q. Right? ये plus Q, ये positive Q को पास नहीं आने देगा. क्यों? ये like charges है. So we have to push this charge. Okay? But कितना force use करना है? जितना force इस इलेक्ट्रिकल चार्ज है उस डायरेक्शन में लगता है इतना ही फोर्स यूज करना है. सो होगा क्या? सो F external will be equal to the F electrical force. Since both the forces are in opposite direction, we use negative sign over here. Again, you use F external force to bring the Q to a point P which is closer to the source charge. You have to use F external, but कितने अमाउंट का, जितना ये चार्ज उसको इलेक्ट्रिकल फोर्स रिपल्सिव दे रहा है. You getting my point, right? So here F external is equal to minus Fe. Got it? यहाँ पर मैंने मेंशन कर दिया है लाइक पॉइंट R is at an infinite distance. For example, कोई भी डिस्टेंस आप ले लें, कोई भी डिस्टेंस कंपैरेटिवली लार्ज डिस्टेंस पर होगा तो हम उसे इनफाइनाइट डिस्टेंस बोलेंगे. क्यों? बिकॉज इलेक्ट्रिकल चार्ज जो है उसका इलेक्ट्रिकल फील्ड का रीजन जो होगा वो छोटा होगा. You getting my point? The range of the electrical charge will be smaller compared to the other forces, right? Okay. Now we divide this entire path in dr small displacements, right? Now we will find out work done by test charge to move this small distance, right? To move this small distance. Okay. Now does force due to this positive Q within a small distance will change at a large distance? No. Why? Because this distance is very large and variation of the force will be not there. You getting my point? Force वहाँ पे vary नहीं होगा. Got it? That is why we divide this entire path in small elements. Got it? So first to find out work done in a small distance. Right? So how much work will be done? This is what a dW is equal to force multi displacement. How much force you use? F external to bring this charge near to the source charge. Right? Okay. And how much displacement you use? So this is the small distance or displacement, say dr. Right? So dW is equal to F external into dr. Got it? This is what the work done by force F external to move plus Q by distance dr. Okay? Okay. Now, when you bring this charge Q from infinite to point P, with what velocity or with what acceleration will it move? So यहाँ से हमें पता चल गया. Since both the forces are opposite and having the same value, net force acting on the charge will be 0. यहाँ से हम जो external force use कर रहे हैं उसको लाने के लिए कितना, यहाँ से जितना repulsive force लग रहा है. That means both the forces are having same magnitude in opposite directions. Right? So we'll cancel away. So net force act on the unit charge will be 0. And we know when net force act on the body is 0, what happen? If body is in a stationary position, will remain in the stationary position, and if body is moving with some velocity, will continue its velocity. You get it? That means when force is 0, this charge particle will move with a constant velocity. You getting my point, right? Okay. So now यहाँ पर हमने find किया work done to move this Q, this small distance dr against the electrical force of the Q. And here work done कितना आया? dW is equal to F external into dr. So this equation is number 1, right? Okay. But we are interested in what? Total work done कितना होता है? यहाँ पर लाने के लिए, right? So ये continuous process करते रहेंगे, right? Okay, so how many dW we got? Many, infinite, right? So dW within this small displacement elements at dr, and through all the displacement force F external is remains constant, right? Okay, so what we do, we just take integration over the path from infinite to point P, right? So total work done W is equal to integration from infinite to point P, given point P, of what? Of the small work done occurs in the small displacements. Got it? Okay. So use this value of dW over here. We get is equal to integration from infinite to P F external into dr. Now we have relation. I want to use electrical force there. So F external is equal to what? Minus F electrical force. So use F instead of F external, hence you have to go with the negative sign, right? So work done is equal to minus of integration from infinite to P force of electrical force into displacement. You get my point? राइट ओके इतना वर्क डन होगा ये चार्ज को इनफाइनाइट से इस पॉइंट P पर रखने के लिए you get my point and whatever work has done will store in terms of potential at that point again work done by the charge q will store in terms of potential at that point got it right so we can write this work done as a potential and potential is indicated as a v how we indicated v potential at the point p potential at the point P is Vp is equal to similar this relation minus infinite to P integration fractional into dr. Got it? Right? And finally, unit of a potential is volt. We indicate it as V. You get my point? Right? Okay. Now, let me revise it a few broad view we can say. इलेक्ट्रिकल पोटेंशियल हमें फाइंड करना है कहां पर इस पॉइंट पर यू कैन फाइंड आउट इलेक्ट्रिकल पोटेंशियल एनीवेयर इन इलेक्ट्रिकल फील्ड ऑफ द क्यूब गॉट इट सो लेट मी चूज सिंपल पॉइंट P यहां पर इस पॉइंट का इलेक्ट्रिकल पोटेंशियल क्या है ये फाइंड करना है सो वी टेक वन यूनिट पॉजिटिव चार्ज वी ब्रिंग दिस यूनिट पॉजिटिव चार्ज फ्रॉम इनफाइनाइट टू पॉइंट P whatever work done by the charge q against the electrical force of the source charge is called the electrical potential but kahan par at this point P you getting my point so look at the definition again definition work required to be done against the electrical field in bringing a unit positive charge highlight a unit positive charge from infinite distance to the given point in the electrical field is called इलेक्ट्रिकल पोटेंशियल एट दैट पॉइंट दैट मींस इलेक्ट्रिकल पोटेंशियल कोई पॉइंट का होगा कोई पोजीशन का होगा कैसे फॉर एग्जांपल इस पॉइंट ये लोकेशन जो है इसको कहां पे रखते हैं फॉर एग्जांपल यहां पर सो डिस्टेंस विल चेंज व्हेन डिस्टेंस चेंज दिस टोटल डिस्टेंस इन द वर्क डन विल बी चेंज hence work done will be changed and hence potential will be changed that means potential is depends on the point you choose potential कोई जगह का okay clear right so when work is done by the unit positive charge again unit positive charge this is not a charge having arbitrary value got it right unit positive charge this potential will be stored in terms of work done at the point P got it and its formula is Vp is equal to minus of integration infinite to P fractional into dr right इसी तरह आप कोई भी पॉइंट पर पोटेंशियल फाइंड कर सकते हैं फॉर एग्जांपल नाउ आई वांट टू फाइंड आउट पोटेंशियल से एट अदर पॉइंट r so infinite this is our point P I want to find out potential set r at r right potential at P is Vp right now let me proceed for r so what we did we divide this entire path in a small displacement elements having length say dr so work done in this small displacement is dw so to find out total work done we take integration of this small work done from where to where infinite to r this work done will store in terms of potential at a point r whatever work is done to bring this space charge from infinite to r will store in terms of potential but kahan pe at the point r so is equal to what negative of infinite to r electrical force into dr f into dr got it so same potential we get here at the point r you getting the point right so how many points we have now two P and r potential at P is Vp and potential at R is Vr. Now curious about the potential difference between these 2 points, right? Potential difference कौन सा है, right? Okay, हमें ये potential compare करना है. So what is the potential between this P and Vr directly, right? So we take potential difference delta V is equal to V. You can write delta V and V is equal to Vp minus Vr. Vp minus Vr. Question होगा ये क्यों कर रहे हैं? Because potential at a single point makes no any sense in the physics. यू गेटिंग माय पॉइंट? ये कहां पे यूज नहीं होगा, हमें पोटेंशियल कोई 2 पॉइंट्स का कंपेयर करना होगा और देखना होगा कि कौन सा पोटेंशियल हायर पे है और कौन सा पोटेंशियल लो है। यू गेटिंग माय पॉइंट? सो वी हैव टू टेक अ डिफरेंस between potential at the 2 points. Got it? We call it as potential difference, right? So potential difference लेने के लिए at a point P and at a point R हम क्या करेंगे? Delta V is equal to V is equal to let Vp is this value integration f into dr minus Vr is this value f into dr जो यहाँ पे मेंशन किया है. Take a subtraction of both this value minus integration f into dr जहाँ पर हमने फिनिश किया था, right? into plus क्या क्यों प्लस यहाँ पर, बिकॉज ये नेगेटिव है, नेगेटिव नेगेटिव पॉजिटिव इंटीग्रेशन इनफाइनाइट टू r f into dr, राइट? ओके, नाउ यहाँ पर देखिए ये नेगेटिव को मुझे रिमूव करना है. आई वांट टू रिमूव दिस नेगेटिव साइन, राइट? सो आई विल स्ट्रिक दिस लिमिटेशन ऑफ इंटीग्रेशन, राइट? इंटीग्रेशन इनफाइनाइट टू p जो है उसको हम इंटीग्रेशन p टू इनफाइनाइट कर देंगे, राइट? whenever you have something like this integration x to y, right? if you take negative of it becomes y+, जो पोजीशन will change. यहाँ पर हमने किया था इंटीग्रेशन from infinite to p. if I take negative common outside the integration then our integration will change, its limits will be changed, p to infinite. We go in reverse to it, right? Okay, so when negative value comes outside of the integration its limit will be changed, so limit होगा p to infinite जैसे यहाँ दिखाया है. when negative comes out there is already negative sign there, negative become positive, right? Remaining other things are against them, right? Okay, now see ये हुआ क्या, यहाँ पर देखिए p to infinite यानी कि हम p से infinite तक गए, हम p से infinite तक गए जो हमने इंटीग्रेशन की लिमिट अभी चेंज की, दैट इज व्हाई. देन इनफाइनाइट से r तक वी मूव इनफाइनाइट से r, दैट मींस p to infinite then infinite to r. So this is the direction of our way. Again p to infinite to r, this is the path of the particle. But does it matter here in the terms of field, since electrical field is conserved? No, conserved electric field में path matter नहीं करेगा, right? Only initial and final positions are matter. You getting my point? This is the conserved field. So we directly go from p to r by taking initial limit as a p and final limit as a r. You getting my point? So whenever you have something like this integration, शॉर्ट में लिखा रहा हूं, इंटीग्रेशन x to y f of x dx प्लस इंटीग्रेशन y to z f of x dx. अगर कुछ ऐसा है तो हम इसे यहां से x to y then again y to z, then we can go with direct initial to final limits. So integration x to z f of x dx like this. So यहाँ पर भी कुछ ऐसे बन रहा है, कैसे? Our initial limit is p, then we go to infinite. Again we start from infinite, then we go to r. That means initial limit is p and our final limit is r. So we can write it as p to r directly, right? So this difference is equal to potential difference is equal to integration of p to r f into dr. This is what the potential difference between two points. Again, हाईलाइट क्या है पोटेंशियल की? पोटेंशियल कोई जगह का है, कोई पॉइंट का है, कोई लोकेशन का है, कोई साइड का. कहां पर? In the vicinity of electrical field of a source charge. That is, potential is a characteristic of a charge, of a source charge. Got it? Right? So, if I change the position, if I change the location, if I change the distance, potential will be changed. Got it? But if you take 2 points, arbitrary could be 2 points, then potential difference is what more important. You get it? Right? Potential at a single point makes again no sense in the physics. Hence, we have to go with the potential difference between 2 points. हमें ये compare करना होगा. We have to compare potential of the 2 points at the two positions. You get my point?